Hi children, hope so all of you are staying home and staying safe, right? Happily with your parents. As you're seeing over there, if you're staying at home, you can be away from the corona, right? Fine. So today's session will start with a small starter activity. Then next to that we'll do the recap about BOHRS postulates. Then we'll go for what we have done in the last class, that recap. That is nothing but the series of the hydrogen spectrum, which is being explained by the BOHRS postulate. And next to that, with the help of same BOHRS postulate, how the energy associated with each and every orbital of the hydrogen is being explained, as well as the radius of the orbitals of the hydrogen atom according to BOHRS model, and the total energy associated with them with the Rydberg's constant, how to find the value of the Rydberg constant. All these things we'll do, and then as the conclusion we'll be doing like how we have done the Rutherford model with all these things. Then finally we had some drawbacks which could be overcome with the help of BOHRS model. Similar way here also the BOHRS model is also having some of the drawbacks. So we'll discuss them, then how it could be overcome with the help of the quantum mechanical model. That's what we are going to do, right? All of you ready? Yes. Get ready for the starter activity now. What is the starter activity? It's a very simple thing what you can correlate with your middle school days, what you have done with physics, okay? And you can answer this question. You could able to see it here. You need to get this ball towards the downward. You have to get the ball towards the downward without touching the ball. With the help of your hand, you should not push it, or you should not pull it. You should not do anything with the ball with the help of either of your body parts or with the help of any of the other objects. But the ball has to go and it has to touch the bottom of this pan what you're having, right? If you couldn't be able to like visualize this, I'm showing you that practically here. I have a pan, in that I kept water, and on the top of it you have a ball, right? Now this ball has to go where I told you. The ball has to reach the bottom of this pan. How could you do that? 1, 2, 3. 3 seconds is enough for you to think, I think so. Okay, fine. So I'm just giving you a hint. Think about it. Pressure is the thing which is beginning it. Any answers in any of your mind? No? Okay, fine. I'm adding one more clue for it. Air pressure and upthrust you can compare. Okay, by comparing the pressure, air pressure and the upthrust, you can give the answer. Now any idea? Okay, who all got the idea, or who don't have an idea also? I'm just revealing the answer here. When you're taking a glass without touching the ball, if you're going to invert it inside the water to like in the place of the ball, as you're seeing it over here, the glass will be having the air pressure which is going to be acting over inside it. The magnitude of the air pressure what you have over here is going to be higher compared to the amount of pressure which is going to be given by the water from the bottom, right? So amount of air pressure is more and the water pressure is less. That is, the water can't resist the ball from moving it towards the downward direction. So what will happen as a result of it? The ball will reach the bottom of the container without touching it, even with the help of the glass. Just with the help of the air pressure, it will be moving towards the down, right? So all of you get ready with the glass and a pan to do this magic with the kids who are all there in the home to have a good quarantine time, right? Okay, fine. We'll have a recap about the BOHRS model now. You could able to see it here. The BOHRS model, we discussed about all these things. BOHRS model or the Rutherford model tells us that the electrons are revolving around the nucleus like the planets are revolving around the sun. So this is going to be a nucleus and all these are going to be the electrons, right? The similar thing I'll be showing you with the help of the image over here. Could you able to see that over here? Comparison of the solar system and the model. And what is the important drawback about Rutherford model is, if it is going to be stable circular one, then the energy will be lost and it is not a stable one. That's what you're seeing when it's going to continuously revolve. How many of you remember the example I gave you? If you're going to run continuously, starting you will have higher energy, then when time is keep on going, at a point of time you will be losing all your energy, then after that you will not even able to make a step, you will fall down. Similar thing applicable to the electrons as well. When they are going to revolve continuously, at a point of time they will be losing all their energy, and by the attraction of the nucleus they will fall into the nucleus. Exactly, you're seeing it over here. So if it is going to fall into the nucleus, there is no existence of the atom. If there is no atom is going to exist, we can't say what is the matter is, and nothing cannot be possible in the universe. So that model which is being said by the Rutherford is wrong, and we came up with the idea that yes, they do liberate energy, but the energy release is due to the transmission of electron when it is going to move from higher to lower energy or lower to higher energy. That means that the orbitals are not stable, but they do have a definite energy associated with them. Because of that only, when they are moving from one energy level to another energy level, if they are releasing energy, that will be visible as the emission spectrum. If they are going to absorb energy, that will be absorption spectrum. Continuously liberating energy, that will be a continuous spectrum, right? So a very big hi to this person who gave this chapter, or who gave the basic matter what we have, who is Niels Bohr, and he what is a model proposed by him is called as Bohr's atomic model. He got the Nobel Prize for it in 1922, right? So the postulates, what I told you, again we made this as a gist in your board work notebook in the last class. Hope so all of you will be seeing the notebook now once again to have a review. So the orbitals are going to have definite energy levels, first point which you need to remember, and it never gains or loses energy when they are going to stay in that particular orbital as long as an electron remain in a shell. If n is equal to 1 state, it is going to be there. How many of you remember the example what we have done? For example, I told you the energy associated with the n is equal to 1 level is 3 joule, and this is going to be 10 joule. So if an electron from this n is equal to 3 wants to go to n is equal to 1 state, what it has to do? It has to liberate the energy of 7 joules. This energy 7 joules, what it is going to liberate will be in the form of light. That is why this energy liberation will be given by del E is equal to h nu. Do you guys remember that? If this electron is going to stay in the same n is equal to 3 orbital, then it will have the same 10 joules only. When it is going to move to n is equal to 1 only, it is going to become 3 joule. Unless otherwise it remains in the cell, it will never gain or lose energy. That is what is the next postulators. This one also we discussed. How many of you remember? Okay, we'll just have a small recap again about this point. If the electron is going to move from the ground state, what do you mean by the term ground state? How many of you remember about it? The ground state is nothing but the electron is going to be at its lowermost energy level. The lower energy level of any of the element is going to be called as ground state. About to that, whatever the higher energy level you are going to have, all those higher energy levels are going to be called as excited states. So from a lower energy level to a higher energy level, if the electron wants to move, it has to absorb the energy of h nu. If it wants to move from the higher to lower, then it has to release the energy of h nu. This is how the emission and the absorption spectrum is being done. Do you remember? This will be coming under the absorption spectrum. This will be giving you what is called as the emission spectrum is, right? And when you are going to look at it over here, this is what is the fourth important postulate which is being given by Bohr. That is the angular momentum of the angular momentum of the electron is going to be equal to what value? N pi 2 pi. According to quantum mechanics, this is what is the angular momentum of any type of wave nature particle. That is, the particle which exhibit both particle and the wave nature will be having the angular momentum like this. But he was not aware of this wave nature, like dual nature of the electron at that time. But he proposed a value over here. The angular momentum of the electron should be equal to this. Then this will be this is going to be possible for the electrons to stay in that particular orbital. That is what it is. So if you are going to, the angular momentum of an orbit depends upon the quantum number, which is the principal quantum number we said, and it is the integral multiple of the factor h by 2 pi, right? So n is going to be the number of orbitals in which the electrons are going to be present. Now recap about the last class. So how many of you remember last class, a sentence what we have done? How many of you remember? Myanmar, yeah, Myanmar, pasta, bread fund. Myanmar, pasta, bread fund. What does that mean? The Myanmar pasta red bread is nothing but Myanmar. Myan represents the sound of lemon. Like Myanmar, mer represents Balmer. Then what we said? Pasta represent Pashtun. Then what we said? Myanmar, pasta, bread. Bread is nothing but blanket or the bracket series. Then fund is nothing but P fund. So this order tells you that where from the excited state where the electrons are going to come down, which is going to be n is equal to 1 for the Lyman series, n is equal to 2 for the Balmer series, n is equal to 3 for the Pashtun, and bracket 4, P fund is 5. Then the other series will be H infinity, and the Hampuri series we will be doing, which we are not going to discuss now, right? And I told you guys to try this out in your notebook. How many of you tried it? I don't know. 1 by lambda is equal to R into 1 by n1 square minus 1 by n2 square. This is what is a general formula which has been obtained by the BOHRS experimental data, and with the help of this only he found all the starting and the ending values of the spectrums I told you, right? And I said you to check with this as well. Always for the Lyman series the n2 value will be 1 only. For the Balmer series 2. For the Pashtun series 3, bracket series 4, P fund series 5. And this n1 is going to be the energy level from which that electron is going to come to the n2 level, right? Suppose if you are going to take the n1 over here as the first level, that is from the second n is equal to 2 to 1 it is going to come. At the time, if you are going to find out the value of this, like by substituting the Rydberg constant and n1 n2, if you are going to substitute, what is the wavelength you are getting, that is what exactly been written over here. Could you able to see this? Which is going to be the higher wavelength, 121.57. Same way, at n is equal to infinity level, if the electron is going to come to the n is equal to 1 level, what is the wavelength you are going to have is going to be 92.62 nanometer. As you are seeing it, which is less than 400 nanometer. What is the value you have over here is going to be less than 400 nanometer, which shows that it is going to be not in the visible region. That is why it is going to be available in the ultraviolet, I told you. Similar way for the Balmer also I said you to substitute. So the n2 will be taken as 2 and the first n1 value can be written as 3. So that we'll be getting the value of that as 388, which is nearly equal to 400. And if you're going to take n is equal to infinity, that is going to be 656. Continuously, if you're going to substitute like this, the Balmer series appears from 400 to 700. That is why it is available in the visible region. All the others are going to have the higher wavelength, like above the 700. But they are going to be having the value below the upper one. Like in the spectrum after infrared, what we are going to have? UV, visible, infrared, then we'll be going for X-rays, gamma rays there, right? Why we are not having X-rays? The reason for that is X-rays are nothing but the fast moving electrons. Here the electrons are not being liberated in any of the series. They are going to liberate only the light energy. That is why here the release of electron, that is the X-rays, are not possible. Got it? So this is about the revision of the last class. Now in today's session we are going to derive the radius, energy as well as wave number. Don't get confused with this term wave number. Wave number is nothing but 1 by lambda. That is what's the formula we did, right? So with the help of this we'll be able to find the Rydberg constant, that I'll show you in the upcoming slide. Okay, so what is the next thing we are having? We are taking a atom which is having the center nucleus. If you are going to talk about the center nucleus, once again few of you will be having a question, how it is Ze? This is going to be the charge of nucleus. How we got the charge of the nucleus like this? Charge of the nucleus can be found with the find with the help of the formula number of protons into charge of one proton, right? When you are trying to find the number of protons will be given by the atomic number. Atomic number will be represented by the letter Z, and the charge of one proton will be equal to charge of one electron. So the total charge of the nucleus will be given by the formula Ze, exactly what you have here. And charge of the electron is E, mass of the electron is m, the velocity with which the electron is going to move is going to be v, and the distance between the electron and the nucleus is going to be r. By utilizing this, once again, where we will go, all of you remember about Rutherford model. What we discussed is exactly the force of attraction or repulsion between any of the two charges will be given by q1 q2 divided by 4 pi epsilon naught, where q1 is the charge of the nucleus, where q2 is the charge of the electron. We got the formula. Then to which we will be comparing this, remember about the Rutherford model, to the centripetal force or the centrifugal force, which will be given by mv squared by r. So what we are trying to find first, the radius. We have written it here by rearranging them. Could you able to get that? Right? So finally we got it by rearranging them. If you are going to look at it, there is a problem with this. Except this, like z is constant, e is constant, 4 is constant, all these are going to be constant except this v value. So we are going to use the BOHRS postulate to find the v value. According to BOHRS fourth postulate, what we have done, how many of you remember? That is, the BOHRS fourth postulate is going to tell us that angular momentum is going to be equal to nh divided by 4 pi, where the v will be given by nh divided by 2 pi. This m and r will go down. Exactly. Then we are squaring it. Then we are going to substitute this value in the previous one. As the v squared is going to be at the denominator, over here only we had the v squared, right? So the value of the v squared has been inverted and it has been written like this. If you are going to simplify it, then you will be having here as, that is, simplification is nothing but 4 got cancel, pi cancel, epsilon naught won't be getting cancel, epsilon naught won't be getting cancel. Let me take the eraser. Okay, so the epsilon naught will not get cancelled. Then what else we are going to have here? Red will be easy. Okay, the m will get cancelled, and if you're going to look at it, r also will get cancelled with the square over here. Is there anything else what is being left over here? No, right? So let me round off all the other elements which is available over here. So Zt squared should be, we should write it, pi we should write, m we should write, r we should write, and epsilon naught is there, and n squared h squared. So all the rounded off yellow color things are here. Here you have 1 is nothing but 1 by 1 and 1, both of them are same, right? So we are going to cross multiply them. We are getting this equation. Once again we are rearranging and we are getting the value of the r. If you are going to look at it, all these values are going to be constant except only one. What is that? N is going to be variable. All these are going to be constant. So if you are going to substitute all the values and you are getting a number value, that is going to be taken as a naught over here. Okay, that a naught value, by substituting all this, what we are getting, 0.529 angstrom. Please substitute the values and check it on your own as well. So the BOHRS radius will be given by the formula r is equal to n square into a naught. Okay, now suppose the n, first orbital, if I'm going to have n is equal to 1, then what is the radius of the hydrogen atoms first orbital, hydrogen atom second orbital, hydrogen atom third orbital, hydrogen atom fourth orbital? That's what we are seeing. Then here we go, the total energy of the electron according to the BOHRS model we have. So the total energy will be given by kinetic energy plus potential energy what we have. What is the formula for kinetic energy? Half mv square, plus what is the potential energy? Minus Zt square divided by 4 by epsilon naught r. From where we got it? How many of you remember the first chapter as well as the BOHRS model we discussed? Yes. So q1 q2 divided by 4 pi epsilon naught r, right? And the potential energy will always be the negative value which we discussed already, right? That's the same thing we have. q1 is going to be Zt and q2 is going to be E. By substituting it, we are getting it over here. Were you able to understand this? Then the next step, by multiplying this, we'll have a minus over here. Look at it. From where we got it? Just now we discussed about it, right? In the first slide over here. How many of you remember this step, right? mv squared is equal to Zt squared divided by 4 pi epsilon naught. So from this first equation, we are getting the value of the v over here, so that we can substitute it for the v squared in the previous slide. So v squared we have it, right? So this v squared value we have it. Over here we are going to substitute that. So because of that we are taking the equation 1. From equation 1, if you are going to take that over here, V squared only you want, so the m will go down over here. So Z E squared divided by 4 pi epsilon naught can be substituted. So half m V square is going to have Z E squared 4 pi epsilon naught or 1 m over here. So this m and m will get cancelled. That is why you have the rest of the term over here, where this 2 into 4 will give you 8 over here. So Z E squared divided by 8 pi epsilon naught r minus Z E squared. Hope so all of you know to take the LCM. Commonly we have taken the term. Half minus 1 will be giving you minus half. So we got once again the similar energy. This minus sign indicates that the electrons are intact to the nucleus attractive force. Yes, that is how the model has been accepted as correct in the Rutherford model we have done. The similar thing you have over here. Could you able to understand this? Now putting the value of the R from equation 5 into the equation 8. Where we see the equation 8? Here. So this R value is going to be replaced now. What is the R value? Z is equal to 1 we will be substituting for the hydrogen atom, and the R value equation has been substituted. By simplifying this we got, now from this you could able to write like all the terms whatever we have over here, all of them are going to be constant except the n. So from this we are trying to prove that n is the only factor, that is the orbital in which the electron present is going to decide that what is the energy it is going to hold. No other factors, all the others are going to remain constant, right? That is what exactly you see here. N is the factor which will be deciding this. So the value of all this constant we have written over here. The minus value together is being given as k, that is we are taking that as a constant. The negative sign indicates that the decrease in the energy of the electron, that is when the electrons are going to move, they will be having a reduction in their energy, right? Now what we have done for the radius, the same thing we are doing. But before that we are doing one more thing as well. We are converting that into mole. A quantity what you have, if you want to convert that into numbers of atoms, then you will be multiplying it by Avogadro number. That's the same thing we have. I want to convert that into kilojoule, so I'm multiplying and dividing it with the 1000. So when I'm going to multiply 1000, that multiplying 1000 can be written as this kilo, what I have written here, and dividend 1000 is here. This value we know, when we are going to multiply this value, this Avogadro number and 1000, the simplification is going to give us the value like this, right? So the energy associated with 1 gram of hydrogen atom will be given by this formula. Now n is equal to 1, 2, 3 we will be substituting and we will be seeing. See, you could able to see it here. N is equal to 1, n is equal to 2, n is equal to 3. If you are going to substitute all this value, you could able to observe one thing. That's the same thing I showed you here in terms of the hydrogen atom. N is equal to 1. You could able to see minus 1313. That means that in minus it is a higher number, means that is going to be the lower energy. So that is why it's a ground state. All of them are in minus less numbers. In minus less number means that is you are going to have a very less depth with you. That means that it is going to be the higher value. If you borrowed a money of 1313 from some other person, yours seems to be having a very less potential. If you borrowed only less, like 50 rupees only, then you will be taken as a high potential person. That means that the potential, the energy over here is going to be more. That's how it has been arranged over here, right? Then the next thing is very, very simple. What we are doing here, once again, n is equal to 1, n is equal to 2, n is equal to 3. The same factors over here. Now we are trying to find out only for the n is equal to 1 and 2 levels alone. From n is equal to 1 to an electron n is equal to 2, it's going to move. So the energy is going to be E1 over here. The energy is going to be E2 over here. What will be the amount of energy lost or gained is going to be given by E2 minus E1, which will be given by h nu, right? Exactly, we are writing it over here, but we know the formula for the E2 and E1 with the help of previous derivation. We are taking all those terms commonly out. Then Z will be given by 1 for the hydrogen atom. We have it over here. Then this del E can be replaced by what I said? H nu. That is what exactly we are going to substitute in the next slide. Could you able to see that? So all this constants value we have substituted, that is giving you 2.18 into 10 power minus 18. Then the h nu you are going to substitute. Now the h nu you are going to substitute, I am going to have only the nu value, because when we are looking at this equation, you would have been seen that this n square value 1 by lambda is equal to we will be having. So I'm going to keep this nu alone to write it in terms of the lambda. So I'm taking the h down, right? So when I'm going to take the h down, could you able to see that? The same constant terms, the h down is, will be making this as h cube, right? So the frequency will be given by this final formula like this. When you are coming for the next step, V is equal to C nu bar. Don't get confused with this. All of us know this factor that the velocity will be given by displacement over time. In a wave, or the velocity of that will be light wave. Velocity will be c, the distance will be the wavelength, and t will be the time period. This could be written as lambda into 1 by t. This 1 by t is nothing but frequency. I am writing this frequency here as f. So here the c will be given by lambda into frequency. If I want the frequency alone, how can I write it? The frequency will be given by c divided by lambda, right? Now the frequency is equal to c into 1 by lambda. I can write this 1 by lambda is nothing but wave number. What is the bar what you are seeing here? Now could you able to get that? How we are getting this? That's the same thing we have over here. Instead of the frequency, we are substituting the wave number into velocity of the light. Then the c is being taken down, right? Now the wave number is going to be given by, wave number is nothing but what? 1 by lambda is going to be given by this value. If you are going to substitute all this, finally, ta-ta, we got that is nothing but the Rydberg constant what we are using in the formula, right? What is this V bar is? Wave number, which is nothing but 1 by lambda. That's it. We have done with that. Now we are going to look into the drawbacks of this. What are the drawbacks I said? According to the BOHRS model, we could be able to explain the change of energy, but they are in the form of radiation. That we couldn't be able to explain. Then we couldn't be able to explain this spectral lines when they are you could able to see the background. The single lines like red, blue separately we could able to explain, but this cluster of lines what you're seeing, that we couldn't be able to explain. Then the next factor is for hydrogen and helium and lithium, very smaller size molecules or the ions only, the spectrum could be explained with the help of Bohr theory. Not for the higher elements, we couldn't be able to explain the spectrum. And when the spectrum is being subjected to a magnetic field, what is the effect we are going to see in the spectrum is called as Zeeman effect. That also we couldn't be able to explain with Bohr model. Then the same thing is being situated to electric field. Then that will be giving you a Stark effect. That also couldn't be able to explain with the help of the BOHRS model. When we are coming for the last point, all this we couldn't be able to explain. The reason is Bohr considered the electron only as the particle. The particle is going to have a single plane movement only. We can't be able to explain the three-dimensional motion of it, right? And when we are coming for the last one over here, all this are going to be explained with the help of, that is the Bohr's assumptions that an electron is an atom is located at the definite distance of the nucleus revolving around with the definite velocity, and it has a fixed momentum. This idea is not agreement with Heisenberg uncertainty principle. What does it mean is nothing but, if how many of you remember the example what I used to give in class? That is, if a fan is going to rotate slowly, you could able to count the number of fins associated with that. Suppose if it is a fan, it will be having 3 fins associated with that. Slowly if it is moving, you could able to count it. But when it is going to move with higher speed, you will not be able to count it. You will be saying that as energy, right? That means that when something is going to move with a higher speed, you will not be able to find the position of that as well as the momentum. Momentum is nothing but what? Mass into velocity. So the velocity and the position of a fast moving particle cannot be found at the same time. Then how can you say that the electrons are going to be available in the particular position, that is in the orbital? That is how it failed. Okay, but that could be explained with the help of the wave nature duality. That means that a particle which is in a macro state, that is when it is going to move slowly, it can act as a particle, or the movement of that can be taken as a particle. When it's going to be move faster, that could be taken as a wave, which will be called as the duality of matter. Okay, that will be called as the duality of matter, what we are going to take. Then the duality of matter can be like accepted or can be proved with the help of this. That is, in a matter wave, the momentum will be given by mv. When it is going to be in the wave nature, the momentum of that will be given by h by lambda. So a particle which could act as a particle wave or a wave particle, that should have a wavelength of lambda is equal to h divided by mv, which is called as de Broglie wavelength. Okay, this is applicable to only the microscopic particles, which is going to be small and with a higher speed, not for the macroscopic particle. This is justifying the fact what we are discussing. So the electrons could able to revolve around them as we are seeing it over here, right? If they are going to have a revolving around the nucleus, then the distance what they are going to be covered will be given by the formula what? The distance will be covered by the circumference of the circle, which will be 2 pi rn, right? Into what is this? The distance will be given by the formula n lambda. Then what else we are doing? De Broglie wavelength will be given by, in the previous slide we did. Now this lambda will be replaced with this value. Then we are getting the same thing what we discussed as Bohr's postulate. So with the help of quantum mechanics, that is dual nature of this electron, we will be able to have the electrons which is going to be revolving around the nucleus, but they are not going to revolve in the circular orbits. They are going to be revolving around the nucleus in the elliptical orbits with a higher amount of energy transition. Okay, that's it. With this we came to the end of the chapter. And about the homework, in the last class I gave the homework as the in-text questions of 12.1 to 12.5, but so many of you haven't completed this 12.1 to 12.5. I didn't receive them. All of you are grown up. Please focus on your studies. You have much time to spend for the studies now. Please do them and then send it to me, or otherwise you will be losing your marks, right? And for today's, that is 24/2020, what is the homework you are going to do is already 12.4 up to that I have given you, I hope so, right? So from 12.5 to 12.10 you are going to do it in your homework notebook and you are going to send it within today, right? Okay darling, all of you please stay at home and then stay safe. I'll see you in the next class, right? Bye.